right? So the shell is also a layer in the operating system, but it is on top of the kernel, right? It is on top of the kernel. And so we take an advantage of the shell commands, right? Or we take an advantage of the system call. So there are two components here in this area. One component is called shell, and shell allows you to write the commands on the terminal window, on the CLI, right? Command line interface, right? So you have a command line interface where you can actually write the commands, or if you want to do the programming, if you want to write, if you want to call the kernel functionality within your C code, then you have to call what we call system calls. Okay, what we call system calls. So if you would have studied, let's say, any basic programming course like C programming or something, you would have seen that we make a call to, let's say, for example, in the file management area, right? You open a file, right? When you open a file, you have to call some function, and that function is actually part of the kernel. It is a system call function which you are calling to open the file. So you're basically instructing the operating system that you want to open this particular file, which is located at this place, right, in your file structure, right? So such things can be done, and that is this middle layer is what is important to communicate between the application program and the kernel, right? So that is what we need to really understand. Now I'm going to cover a little bit about the Unix, Linux basic commands, and the same commands actually work also in Ubuntu, because as I said, Ubuntu is actually built on top of Linux, right? So the Linux was built on top of Unix, Ubuntu is built on top of Linux, right? So the commands that we are going to go through here, they will work also in Ubuntu. So first of all, if you have installed the VirtualBox with virtual machine, right, you would basically see Ubuntu installed like this, right? If you go to the Moodle page, which I have asked you guys to enroll into, right? I've actually added a couple of more files here. So in the previous lecture, I told you that I have added an instruction to install the Ubuntu on the virtual machine, which I hope everyone is able to do. Other thing that I had mentioned, that we can actually share, right? We can share the files from the host operating system to the guest operating system. So for example, in my computer, what I have done is I actually have all the files that I want to use in my guest operating system. It is actually located in this folder. So I have a VirtualBox folder in my Windows machine, and I have a shared file folders, shared file folder here, which basically has all the code that I want to actually use in my Ubuntu, which is my guest operating system. So in order to do that, if you look at the instruction, I've shown you how to create that shared folder here, right? So once you create the shared folder here, in this option of the Oracle, VM VirtualBox, you will get this name called shared files. So shared files is the name of the is the name of the folder, which is basically pointing to your host folder. So you see that I have given the path to my host operating system folder, and I've given this as a nickname. So this is kind of like a nickname, or a short name assigned to this particular path. And then what I need to do is that using this particular folder, using this particular name, I need to actually access those files in my Ubuntu folder, Ubuntu operating system. So in order to do that, what I need to do is I need to run some command. Okay, and what is that command? So that command is what I have provided you in this shell file. So what I'm going to do is I'm going to open that file for you so that you know what that command is. So basically we have to run something called as mount command. Okay. So what the mount command does, it takes the a nickname that we have provided to the folder which is sitting in our host operating system to so it is basically mapping this folder to the folder in my guest operating system. So this is where the folder is created in the guest operating system. Home Ubuntu 20SP. This is my home folder, right? So this is my home directory. So home directory is nothing but the /home folder /user ID. So whatever is your login user ID that you have used, this is my home folder. Okay. So by default, when you open your terminal window or your command line window, it by default goes to this particular folder. In that folder, I have created a new directory called host files. Okay. So what I'm basically saying is that whichever path this particular acronym or this particular name is pointing to in my host operating system, I want that path to be mapped to this path in my guest operating system. Okay, that is what I'm saying. I want the read and write access both, and that access should be given to this particular user ID. Okay, so whichever user ID that you create in your virtual machine, that is the user ID you should use here. So in short, this script is created and I do use it, and that is the same script I have provided in the Moodle also, and that is what this script is, right? So basically what will happen is that once you have your shared files nickname established in your virtual machine, you will be able to use that script to actually then create a link, right, from your guest operating system that will point to the files on your host operating system. And so what the advantage we will get? The advantage will be that we will be able to use the files. We will be able to store the files in our host operating system, but then we will be able to access those files also in the guest operating system. So for example, now if I go to the terminal window, or maybe here, right, I have a host files folder here. If I go into this file, in this folder, you can see that I see these folders, right? And why these folders are there? These folders are exactly the same folders which we are looking at in our host operating system here. So you see in the shared files, I have AIPOS, IBM PISA, OpenMP, and so on. And the same folders you will be able to see here, right? And they are exactly the same folder. They are pointing to the same folders. And all the files that we are going to use in our course is actually located here. So in short, the advantage is that you have the files stored on your host operating system, but then you can access them in the guest operating system. And why we are doing that? We are doing that so that in case in the future, if your virtual machine gets corrupted, right? In case your virtual machine gets corrupted, you don't lose the files. That's the primary reason we are doing that. Okay. So now, once you have your VM up and running, you obviously log into your local computer using the user ID and password, like we always do. If you want to connect to the remote machine, also there is a way to do that. But that I will show you once we, go a little bit further into the course. If you want to know what is the current logged in user, you can use this particular command, right? Who am I? So who am I is the command on the terminal window that you can type. That will basically tell you what is the user that is logged in. If you want to change the password, you can use this particular command. For getting the help for the commands, right, or the system functions. So some of the system functions that we will use or the commands that we will use, if you want to know the additional details, right? So for example, you may know the name of the command, but maybe you don't know all the functionality that that command offers. Okay, how do I get the information about that? So for that, there is a man command that is a common command that is used to get help, right? Help for other commands or system functions, right? Man basically is the short name for manual. Okay, so this is a manual command and it provides the manual for the other command. So for example, if I type something like man, who am I? Right? It will basically tell me. It's a textual format, and you know most of the terminal window commands usually work with the CLI textual format. So if you're not familiar with this kind of environment, you will have to sort of get used to it, right? Because when you work on Linux, Unix in the system area, you will definitely have to work with the command line interface, right? That is a very powerful interface actually for Ubuntu and Linux based environment. So most of the time we will be actually working with terminal window. Okay. So as you can see, it says who am I is basically printing the effective user ID. What is the effective user ID? Meaning that what is the current logged in user ID. Okay, so that is what the command is supposed to do. If I let's say type some other command which I am familiar with, for example, ls. ls is the command that lists the directories and files. Okay, so ls command, it will tell you that what the command does, right? And then there are a lot of other information that you can use. So for example, there are a lot of switches, right? So these are called switches or options, right? So you have a lot of options that you can provide with the ls command, right? So for example, one of the options that I use is called L option, lowercase l. So what the lowercase l does, it provides the long listing format. Okay, long listing format. And what that is, let me show you as an example. So let me open another terminal window. Okay, so let's say if I just do ls, right? So ls will give me only the file names like this, right? So these are the file names. But if I do ls minus l, right? Then you see what am I getting? I'm getting a lot more information here in the listing than just the file names. So this is basically what is known as long listing, right? Long listing. So it basically has an information about the permission. It has an information about the owner, the user who is the owner of the file. Okay. It also has the information about the size of the file. It has an information about the last access, right? When was this file last accessed, and so on, right? So that is the kind of information that you can get when you use the -l option. So there are many other options, as I said, that are available in the ls command. So whenever you are, whenever you know the command name, but you want to know what are all the different options that are available, right, that you can use with this command, you can check those out using the man command or a manual command, right? So that is what we can do. We can also check for some of the function information. So for example, if I want to know what fopen does, fopen is one of the function that we use to open the file. Okay, so fopen is the function, and so it says that you have to use this header file, and the syntax of that function is this, and these are the parameters that you have to pass, and so on, right? And then what are the different options that you can again provide in the function. So all the details about the functions is given in this man command by this man command, right? So man command is actually very powerful. If you know the name of the function, or if you know the name of the command, then you can type that after, followed by man, and then you get a lot of good details about the commands. There are various editors which are there. There are some non-GUI editors. If you want to try them out, you can. But I generally tend to use the GUI-based editor because we have at our disposal, right? So we will be using gedit as an editor. And in order to invoke gedit, you have two options. One is you can go to this terminal window and then you can type gedit, right? And then you can start writing your code here or whatever you want to do, right? That is one option to open the gedit. The other option is, again, you can go to this activities. You can click on this activities and then you get this search box. Then you can type gedit and then again open the editor, right? So one of the two options you can use to open the editor. So that is your GUI based editor, and it is it will take all these different commands that we can normally use with the editors, right? Compiler. So all the code, as I mentioned earlier, that we will be writing in C, right? And for that, we will be using a GCC compiler. So GCC is the compiler that we will be using throughout the course. When you have installed Ubuntu, you should have a GCC compiler. And if you want to check the version of the GCC compiler, you can just use this particular switch. Sorry, double hyphen. And it will tell you, what version of compiler you are using. If you want to get more detail on the GCC compiler, also you can use man command. So GCC man command will give you all the details about the GCC compiler also. Okay. The manual for GCC command is like, 100-page long. It's very, 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 very long, right? There are so many options and so many things you can do with it. The reason being that GCC is a compiler which can be used on many, many, many different operating systems, many different kernels, many different architecture. So for example, the computers, processors manufactured by Intel, processors manufactured by AMD, processor manufactured by IBM, processor manufactured by ARM based systems, right? So a lot of processors has different instructions and the compilation, the GCC compiler actually takes care of all of them, right? And again, if you're not familiar with that, don't worry about it. As we go through the course material, you will get to know what all GCC can do, right? How powerful the GCC compiler is. Okay, so that is what we will be using throughout the course. Given some basic commands of the VI editor, which is a non-GUI editor. I don't tend to use it, but in case if you want to just get familiarized with it, just for your knowledge sake, you can do so. Okay. There are file and directory commands. So these are some of the directory commands that there are very common ones which we normally use. So ls, I already mentioned that you want to list the content of the directory. You can use ls command. If you want to change from one directory to the other, right? So normally what we tend to do is, normally we tend to open the file manager, right? And if you want to change the directory, you just click on that directory and it will change the directory automatically. Or you can go back and forth, right? I mean, basically go to parent or so you can basically click on the particular directory to go back and forth. But when you work in the terminal window, there is no mouse, activities here, right? So for example, currently, currently I want to know that which directory I am currently at. Now it is showing me here the directory name, but in case if I don't know, right? The pwd command, pwd is the present working directory command. So present working directory command will basically tell me I am currently at which directory, right? Which folder currently I am at, right? So I'm at this particular folder. Okay. Now, if I want to go back one level higher, right? So for example, this is the level at which I am at. Now I want to go to this level. The option for me is cd ... So whenever you say ... right? ... means parent directory of the current directory. So I'm saying change the directory to the parent directory of the current directory. Okay, so when I say cd dot dot, which means that it goes from this level to this level. So then my directory will become this one. The current directory will become this one. And let me run this command and let me do ls. Or actually I'll do pwd, sorry. So you can see that I went one level up, right? Now again, if I do cd dot dot, I'll go one level up again. You can see that, right? And there is actually, if you want to do multiple dot dot, you can also do that. So I can do something like this also, right? So this is also possible, right? So I'm going to the parent directory and then parent of that parent directory. So I can actually do multiple times dot dot also. That is also possible. So now my current directory is just home, right? Because I went to parent of this one, which is this one, right? Which is this one, and then parent of this one, which is this one. Okay, so you can actually combine multiple of those options also here. If you want to know, if you so dot dot is the parent, right? Now let's say if I want to again go back to this directory, what I do cd / home / ubuntu and like this, right? So I can actually type the whole path where I want to go. And then I do cd, then it will basically take me to that directory. And if I do pwd, you will see that I am actually at that particular location. So cd is basically the command to change the directory. If you want to create a new directory, you can do make dir, remove directory, rmdir, and so on. Right. So double dot basically represents the parent directory. Single dot represents the current directory. Single dot represents the current directory. Double dot represents the parent directory. So these are about the directory operations. Now we have some file operations. If you want to copy a file, right? Copy a file from one directory to another, or maybe you want to have a duplicate copy of the same file in the same directory, then you can use cp command. Okay. Renaming of the file or renaming of the directory can be done using move command. MV stands for move, right? You can remove the file. Right, deleting the file or removing the file is done through rm command, and then there are many other commands which are here. Cat, hat, tail. Basically, what I'll ask you to do is that the operating system, right? Operating system commands that we have here. There are actually many commands. Okay, and it is almost impossible to cover all the commands. Through the lectures. Right, because there are just too many commands that that we have in the operating system. So the idea is that I will show you the commands as we use them. In addition, I would ask you, or I would request you to explore it yourself also. Okay, because programming type of subjects, right, or the operating system kind of so any such subjects are better explored when you try things yourself, right? So obviously as an instructor, I can definitely provide you the sufficient information so that you don't get lost with the subject, but the content, right, the amount of information that is available for all these subjects are just too vast, right? And unfortunately, everything cannot be covered in the lectures, right? So I'll definitely give you sufficient information for all the topics that we covered. However, I urge you to go through this material yourself and then explore it yourself also. Because unless you explore it yourself, you will not be able to really understand the topic, right? So that is what I would ask you to do. Okay, files and directories have permissions. Okay, so when we say permission, what does it mean? It means that who can read the file, who can write the file, who can execute the file, right? So basically, whenever you have the file, you can either read it, write it, or execute it. If the file is an executable kind of a file, right, a file that can be executed, that can be run, you need the execute permission also. Okay, so basically file permissions are R, W, and X, and each of these permissions are given to three types of users in the Ubuntu operating system. So one is called the current user, the current logged in user, which is what we call user. Okay, the second one is called group, which means that every user is part of some group. Okay, every user is part of some group of users, right? And then the group has several users in them, which includes this user or it may not include this user also, right? So the group which is having a current user, and then the other users, meaning that the users which are not part of this group. So there are three kinds of permissions that each file or each directory will have, right? And how do we check that out? So there is an ls command that I showed you earlier, will basically give us that information. So when I look at -l, right, it gives me this first thing. Okay, so this first thing is basically the permission. So you can see that there is an RWX here, right? So this RWX first group of RWX basically says that what is the permission given to a current user, which is this one. Current user is this one, right? Which is what is logged in with. Then you have the access for the group and then the access for the other users. Meaning that if the owner of the file, owner of the directory is this user, right? But if on the same system, if some other user has logged in and that user tries to access this directory, what will be the access given to that user? That is what you have. Now you will see that all of them are RWS, RWS, RWX. But when we go to some other folders, for example, let me go to the home folder. You will see that there are a different set of options given, right? So for example, here you have RWX, RWS, RWX, but then here there are RWX for the current user. The write permission here is not given. You can see that the write permission is not there, and also here write permission is not there, right? So you can change the permission according to your requirement, right? Here you can see that the execute permissions are not there. For the current user and the group user, also write and execute permissions are not there for the other users. So you can change the permission, and to change the permission, you have to use something called as chmod command. Okay, so chmod command is what you can use, okay, for changing the permission. Again, I'll show you the examples of each of those, when we go through the material. But again, you can explore these commands using the, when you again do man, you will get more information about the command and how to use them, right? Some of the help also gives you some examples, right? Some of the examples will be given to how to use these commands. Yes, so Harsh, you are asking that if you change the files in guest operating system Ubuntu, will the changes be affected in the host OS? It will be because the file is the same. It is exactly the same file. All we are doing is we are referencing the file in the host operating system, which is sitting in the host operating system in the guest operating system. So it is not a copy. It is an original file. Right? The only difference is that you are accessing those files in the guest operating system. Okay. Are the files on the host OS not accessible directly in the guest OS? No, because you see that the file format is different. Right? The host operating system is Windows. Guest operating system is Linux. So there has to be some conversion done. And that conversion is done through this VirtualBox software. So no, directly files are not accessible. What is the meaning of depermission? So depermission is actually, D is not a permission. It is indicating a directory. So D stands for directory. L will stands for link. And then if there is no character there, then there is a regular file. So again, if you don't understand this, don't worry about it. when we cover file management module, I will give you more details on this one. So Kali Linux, I have not used it. I don't know whether it has all the system calls that we are going to be implementing in our, in our tool or in our course. So even if you have Kali Linux, I would advise VR that you install, VirtualBox on that Linux, on your host Linux environment. Okay, and then install Ubuntu. So basically, we don't want to play around with your original OS installation, is what I'm trying to say. Okay, so don't try to mess up the original installation. What was D and I before RDB? Yeah, so that's what I said. It's a directory and L for link. Okay, so that is what it is. And again, some of the information I'm going to cover in more detail as we go through the through the different modules. So here we are talking about file and directories. File and directories, I have a completely full chapter which will be there, where I will be covering this in more detail. Okay. So every operating system has an admin user. For the Unix-based environment, it is called a root user, right? So it's basically an administrator. It has access to everything. It is also known as a super user. Okay. If you want to run a command that will have to have the access of a root, you can use a sudo. You can use a sudo command to actually run the command as a super user or the admin user. Okay. Again, I'll show an example when we come to that. Any operating system that you have, or in fact any any system that you have, we must have three files by default. All the devices that you have on your system are considered as files as far as the Unix operating system is concerned, or Unix based operating system is concerned. So whether it is a Unix, whether it is a Linux, whether it is Ubuntu, whether it is Solaris, whatever OS you are using, which is built on top of the Unix system, you must have at least these three files by default, and they are always created by the operating system kernel. Okay, so the first one is standard input, which we basically call stdin as the acronym that is given to that standard input file, and it has the file descriptor of 0. So what is a file descriptor? File descriptor is the number assigned to open files. So whenever you open a new file, operating system will assign a particular number. Okay, and using that number, you can perform all the subsequent operations. So for example, you want to, if there is a file, right, a regular text file, once you open that text file, you get a new file descriptor number. And using that file descriptor number, you can read and write into that file. Okay. So similarly, even the standard devices that we have on our system. So for example, your keyboard is considered as standard input. So that has a file descriptor of 0. So all the reading from the keyboard is done using this file descriptor 0. All the writing on the display, right? The display that you have, all the writing is done using the standard output or std out using the file descriptor 1. Okay, and std error, okay, which is a third device. So if a program encounters an error, right, you want to also display it somewhere, right, which is generally on the screen only. But basically what happens is that normal log messages, normal informational messages are displayed using the file descriptor 1. And if the program has an error, normally you want to display it using the file descriptor 2. So there are two descriptors for the display device, right? The reason being that this is for the informational messages, normal log messages, whereas this one is for the error messages. So you can kind of segregate them in two different buckets, right? That is the reason there are two file descriptors. Okay, we have some redirection operation. Again, when I cover the shell scripting and the file IO operation. I'll be covering the redirection operations more in detail. Whenever you run an application, right? Whenever you run an application, that application becomes a process as far as the operating system is concerned. So, for example, let's say I am running for example, if I am running ls command, right? So ls command is a file, is an executable file, is a binary file which I am running. And how do I know that? Because if I do ls minus l slash bin slash ls, you will see that there is a file here called ls. Okay, there is a file called ls in my bin directory, in my bin folder. It is owned by a root user and it has this permission over here. And this is the size of the file. This is when it was last modified. Okay, so this is the file that I'm running. So this ls command is nothing but an executable file that is created in the operating system kernel, right? In the operating system kernel, and bin folder has all the kernel utilities, all the kernel executables that I can access. Okay, so what I'm trying to say is that this is basically when I run this file, it becomes a process. It becomes a process. And how do I check how many processes there are on the system? There is a PS command or process status command, right? Which lists the currently active user processes. Okay, so again, I can do man yes, and I can actually see what are the different things that PS command offers. So it reports the snapshot of the current processes. And like I said, process is nothing but a running application, right? Applications which are currently running are called processes. Okay, again, I have a full chapter on process management, so I will cover more detail there. But just to give you a basic idea what is a process, this is the process. If you want to get the information about all the processes running on your system, right, there are various switches that are available here. They've given some examples in the manual page, and there are other switches which are listed out here down below, right? But generally speaking, we tend to use couple of these options. So, for example, if I do PS minus AUX, basically what this is displaying, it is displaying all the processes that are running on my system. Okay, so you can see that it is telling me that who is the user who is running the process, what is the ID of the process, what is the CPU utilization of the process, what is the memory utilization of the process, and so on. What is the status of the process, when the process was started, how much time it has been running since, and then the command or the actual file which is basically running, which is running as part of this process. Okay, so all of these are the processes which are running on your system. Okay, so you can see there are many processes, and you can see that the PS command that I had executed is also running as one of the process, right? You can see that. So it is my user ID, right? Ubuntu 20 SP user ID. This is the process ID for that process, and then all the remaining information here. So you can check the process information here. You can also check. See, some of the process are parent process, some process are the child process. So there is a hierarchy of the processes. So whenever you run a process, there could be a parent process, and then there is a child process and sub-child and so on, right? So if you want to actually get the information about that hierarchy, right, there is another set of switch that you can use, AJXF. That gives you the hierarchy. And how do you know the hierarchy? You can see this, right? So these arrows are basically showing you the hierarchy. So it is saying that you are running the terminal first here in this process, right? Then in that process, you are running a bash. This bash is basically your terminal window. It is your shell window, which is what you are running. And then in that terminal window, you are running the PS command, right? Now, if you see, I have two terminal windows open here. There is one here and there is another one here. And therefore, you can see that there are two bash here, 1 and 2, and both are siblings, right? Why both are siblings? Because they are running in a same terminal window. So one terminal window running one, running this particular bash here, and then there is another bash running here, right? So therefore, you see two bash, and then in one of that window, I am running this PS command. So basically, by looking at the structure here, you can actually figure out that what is the tree, what is the hierarchy of the processes that are running. And how do I know that this process is running in this bash? Is because there is additional information provided here. So if you see that, if we go at the top, you will see the headers, right? This header, the first column here, says PPID. What is a PPID? PPID means parents process ID. Okay, parents process ID. This is my PID, meaning this is the current process's ID. Okay, this one is the parents process's ID. So if I look at the first two values, right, I will know that this process, who is the parent of that process? I will know that, right? And that is what I can also do. So if I go back over here to my example of the bash example, you will see that this one, right, is my current process ID, 2122. This is the parent process ID. Okay. This one is the parent process ID. And you can see that that parent process ID is listed over here. Why? Because this is my terminal window. Right? This is my terminal window, which is this particular process ID. And in that terminal window, I have this one bash running, as well as I have this another bash running. You can see that the parent here is the same. Right? So therefore, we know that this is the process who is the parent of this process as well as this process, right? And then for this PS command process, right? This PS command process, we can see that it is the process ID 3078 and its parent is 2122. 2122 is what? This one, this process, right? So 2122 is the process which is this particular terminal window. This is bash window, which is this one, right? And that one is actually running my PS command. So I don't know if it makes sense to you guys, but if it is not clear, just ask me. I can explain that again, but I hope I tried to make it clear. Now, if you have the processes which are not finishing or hung or something, you want to kill them, you can use the kill command, right? And it will kill the process. You can also put the process in the background mode, right? And then you can bring it up in the foreground mode by using these commands. Again, we will cover all of these things in the process management area, but just giving you the basic introduction to that. Top command allows you to display the utilization of the system. So when I do top, basically it will tell you that which command or which process is taking how much CPU percentage, how much memory percentage, right? And so on. And its PID, its user ID, and so on. So basically it is telling me that how much CPU utilization I have, how much memory utilization I have. And then this will give me the overall information. Right? This will give me the overall information. How much memory is being utilized, how much is available, and so on. Right? So basically top command gives you the utilization of the system. There's also another command called time. Time command allows us to figure out how much time a particular command took to run. So for example, if I do ls minus L, right? And then I type time in front. So time ls minus L. So ls command will be executed, and then at the bottom, it will tell me how much time did it took to run the ls command. So it took basically 0.002 seconds, which is basically 2 milliseconds. Right? So it took 2 milliseconds to run my ls command. If I do time ps minus ajxf, it is telling me it took 6 milliseconds and so on. Right? So you can actually figure out how much time did it took for a command to run. There are other, more complex commands such as awk. So awk command allows you for pattern scanning and pattern processing. Okay, so you can basically do pattern searching using the awk command, and I've given some examples over here. Basically, awk command is something that we don't use very widely in our course, but this is a very powerful command in Linux-based environment. So I thought I would at least give you a couple of examples to show you how powerful it is. So in case if you happen to write a shell scripting down the road, once you go and work for some company, and if you happen to write a shell script, complex shell script, you may be able to take an advantage of awk command, right? So it's a very powerful command, but will not be using that widely in our course. Grep command is used to search for the pattern within the file. Okay, so if you want to search for a particular pattern within a file, that is where the grep command is going to be used. So for example, this is the file where it stores all the users, etc pass wd, right? So if I do cat/etc, cat means display the content of the file. So if you see that this is the content of that file, okay, and the content of the file basically has all the users. So root is the user. There are all of these users which are there in the system, and you will see that one of the user is the one which I have logged in with, right? So it says Ubuntu 20 SP is the user, and so on. What is the home directory for that user, right? And what is the shell that we are using for that user? So for each of the command, you will also see the home directory and the shell that we will be using. Okay. So here this is the home directory, and then this is the shell that we are using, and so on. Okay. So you can basically use the grep command to search for a particular user. So let me just do grep Ubuntu 20 SP /etc/pswd, and you will see that it only provides me that one line where it is able to find this particular pattern, right? So Ubuntu 20 SP is the pattern which I am searching for in this particular file, and that is what I'm getting. Okay, so that is something that you can use the grep command for. There's a find command. So find command allows you to find the files in the directory, right? So there's also a locate command which also does a similar functionality. Again, sed is the another command that you have, which allows you to edit the content in the online mode. Meaning that if you want to change some content in a file, normally what we tend to do is we tend to open the file in the editor, and then we tend to search for some content and then modify the content, right? Search and replace kind of thing. But normally we tend to do that using the editor. Instead of that, you can actually do that using the command, right? So for example, this command allows me to look for a word nick and replace all the nick with John in report.txt. Something like that, right? So what I'm trying to say is, again, sed is a streaming editor, meaning that online editor which allows you to filter and transform the text in the files. Okay. Again, this command is very powerful, but as far as our course is concerned, we are not going to use it much. But I've given you a few examples over here so that you can understand the the power of that command, right? So again, I would reiterate the same thing that there are so many commands, so many things that are available in the operating system, and I'll show you the information that is definitely required, and basic information about certain things which may be required for the course, which may not be required for the course, but it is there in the operating system, it is there in the system. So it's better that you at least have heard about them. And I will give you some of the examples like this, right? And then you can explore more on your own, right? So that is what we'll have to do. Some more commands are there. Ping command we will look when we go through the networking component. Telnet also we will look when we go through the networking component. Locate, I already mentioned that locate command is used to also search for the files by the name. These two commands, right? Uname and the LSB release command. These two commands are actually printing the system information. So what does it mean? It means that, for example, if I want to know what is the operating system that I've installed on my computer, right? If I do LSB underscore release minus A stands for display all the information that you can find, right? So LSB release is providing me this detail. So it is telling me that I've installed Ubuntu 20.04.1. LTS stands for long-term support. And then this is the release version. And then this is the code name for this particular release. So every release, every major release, 18, 20, earlier it was 16. So all of the major release actually has the code word, okay, or code name, sorry. So that is the name given to us. Similarly, you can actually get more information about the system using uname. Uname basically not only gives you information about the system which is over here, right? Operating system which is over here. It is telling me that I have Ubuntu 20.04.1, but it is also giving me information about the computer name. This is the computer name. This is the kernel version. So even though I have one operating system which is Ubuntu 20.04, 20.04 Ubuntu can have different versions of kernel. Okay, it can have a different versions of kernel. So this is the version of kernel which I am running currently. Okay, that is what this is telling me. Okay, it is telling me that I'm using the system which has x86 64-bit architecture. x86 is the code given to Intel and AMD based processors. So all the Intel and AMD based processors are coded with the assembly language called x86, and this 64 represents 64-bit operating system, 64-bit machine, right? So that is the information that I get using these commands. So this is the basic, again, introduction to the operating system stuff that we will be using, right? If you have any questions, I can cover that, or I will go to the next chapter. I'll just basically give you the introduction to shell scripting. Any questions? All right. So then, okay. So first thing, normally, when we learn about Unix-based operating system, we need to learn about the shell, okay, and shell programming or shell scripting. Okay. So basically, what the shell scripting does, it allows you the programming construct. It basically allows you to write a small script, small programs that can do some of the functions of the other languages, whatever other languages can do. So for example, you can run the loops, you can have an if conditions, you can check whether the file is there or not, you can check whether the permission of the file you have is read, write or not, right? So basically, there are certain things that you want to do at the operating system level area without actually writing your C program. So C programs can also do the similar things, but you want to write it in the operating system level commands. And that is what we call shell script or shell programs, right? So there are various types of shells, and these shells are the different shells that can be used in different operating systems. So for example, your Solaris operating system can use a different type of shell. Linux can use different type of shell. Ubuntu can use different type of shell. Unix can use different type of shell. And these are all the kind of shells that you have. Now, when I say different type of shell, what does it mean? It means that some functionality and some syntax of some commands will be different. That is all, right? So as simple as that, if you have the bond type of shell, then bond type of shell has a dollar as your prompt. So what is a prompt? Prompt meaning this, where it is asking you for the command input, right? So whenever on the terminal window, when it is asking you for the command to be typed, you get this symbol over here. And that is basically what is called a prompt, right? So the prompt symbol in the bond shell will be this dollar sign, right? But if you have, a C type shell, then you will get a percentage sign. Okay. So similarly, there could be some difference in the functionality. So for example, if I show you the difference between, let's say, SH, which is a bond shell, and then bond again shell. So let's say if we take a look at these two shells, there is a difference in the functionality there also. And how do I do that? So for example, let me do ls minus l, right? Now, if you see here, the directory, directories are displayed in the in this light blue color, right? In this light blue color. This is a file, right? Files which has the full permission, read, write, execute, all the three permissions are displayed in the green color. The files which does not have execute permissions are displayed in the white color, right? And so on, right? So this functionality is available in born again shell, or it is called bash shell, right? So born again shell or a bash shell has this functionality of displaying the files and directories in different color coding, right? But when you go to this basic shell, this bond shell, the basic shell does not have that functionality. And how do I know that? What will I do? I will actually open a new terminal window and I will change the shell to use the basic shell. So that basic shell program is also available in my bin directory. So I'm going to run that so that now I go to the basic shell. Now, when you go to the basic shell, you can see that even the prompt changed. I don't get all these details over here. So this detail basically says that this is my user ID, logged in user ID, and this is my computer name. All that detail is gone, right? All that detail is gone. I can do PWD and figure out that which folder I am located at, which is this home folder. And now if I do ls minus l here, you see what happens. All the file names, all the directories are in the same color. There is no color coding over here. Okay, there is no color coding. So basically what we are saying is born again shell is a sort of like a superset, or the shell developed on top of Bond's shell, which has more functionality. Okay, so if you use this shell, you may have some less functionality compared to the born again shell, which is what the example that I'm trying to show you. Okay, hope it is clear to you. Now I'm going to exit from here so that I go back to again the original shell. Okay. So basically, this is the different types of shell that you have. Whenever you write a program, right? Whenever you write a shell program, the first thing that you will do is what type of shell that you want to use. That is what you will specify here. So there will be a default shell for your operating system, but it may be possible that there are multiple shell versions that are available on your system, and if you tend to use one particular shell version, then you can specify what you want to use. Generally speaking, in our shell scripts throughout the chapter, we will be using born again shell only, bash shell only, right? Because it has the maximum functionality in Ubuntu. So that is what we will be using. So this is how you can specify which shell you want to use, and that command is called shebang, right? So basically, this particular, this operator, pound and exclamatory operator, is basically the command that gives the information about what shell you want to use, and then you can write the remaining commands like this. If you want to put the comment in your shell script, you will use a single pound sign. So single pound sign followed by anything will be a comment. Variables. Right now, there are primarily two types of variables in in shell, right? In your terminal window or in your shell. So the first type is obviously the local variables, right? And the second type is called environment variables. Okay, so environment variables are the variables which are accessible in the current shell and the child shell. Okay, so probably you are confused about what is the meaning of child shell, right? So let me show you that. Let me show you what is a child shell first, right? And then I will explain about the variables. So if I look at PS minus AJXF, okay, and I'm first going to do grep bash, okay, or actually let me first do PS on. Okay. So when I just do PS, right, without any option, what do I get? I get two process IDs. So basically it is telling me that in this particular shell window, I am running this shell whose process ID is this, and in that shell I am running this command whose process ID is this. Okay, and I want to know the hierarchy of this one, which obviously I can get using that PSAJXF command, right? So PAJXF command will tell me the hierarchy like this, right? So by looking at this, I know that my bash, the third bash, right? So I have three bash running, 1, 2, and 3. And the third bash is running this particular command. Okay, now if I want to create a sub bash of this one or a child bash of this one, how do I do that? I actually run a bash executable in this shell window, So when I run a new shell here, right, this process will become the child process of the shell that is running in this window. Okay, and how do I know that? I will do just PS first. Now you see that there are two bash that you will see, because one was the original one, and then there was another one which I ran here. Now these two are the bashes which are running, but then how do I know which is the parent and which is the child, right? So I again do AJXF. Now you will see that I have this bash, which is my original window. Then I have this bash, which is running underneath this bash, right? So this is my child shell. This is my original shell. This is my child shell. And then in the child shell, I'm running ps minus AJX. And if you want to also know, through here also you can get that information. You can see that this particular shell is the process ID 3174, whose parent is 3157. And you can see that this one is the process ID 3157. So 3157 is the parent of 3174, which is my child shell window. This is how I can figure out that which process is the parent process, which process is the child process, right? So now once I figured that out, what I'm trying to say is that the local variables, when I create the local variables, the local variables are not shared in the child shell. It is only available in the shell where it is created, okay? But when you create an environment variable, the environment variables are available in the shell where it is created, as well as all the child shell that you create within them. Okay, and let me just take that one example and then we will stop. So let me go back to the original shell, and if you want to quit a particular shell, there are two ways to do it. One is you can type exit. Another one is you can press Control D. Okay, so let me do exit. So when you do exit, basically it will exit this particular shell. Okay, it will exit this particular shell. And again, I can do PS AJXF to check that out. So you see that now that child shell is gone. Now I'm going to declare a variable called local var. And let's say I'm going to give a value 1. This is my local variable, right? This is my local variable. I'm not going to make it an environment variable. How do I see the value of local variable? I see using echo command. So echo $local var will basically display the value of that variable. Okay, so I know that this variable is accessible in this window because it is able to display me the content. Now let me declare another variable called env var, and I'll assign the value of that to 2. And if I do echo $env var, it will also display me the value. But now if I'm declaring the variable like this and if I'm declaring the variable like this, how it is different? Well, it is not different. This env var is still a local variable. If you want to make this variable an environment variable, there is an additional command that you have to execute, and that is called export. So you do export env var. Okay. Now when you run this command, it makes the env variable environment variable. Okay, it makes the env variable environment variable. What does it mean? It means that if I do echo $env var, it is available here, obviously, right? Because this is still the same shell window. But now I am going to open a child shell now from here. So I'm going to say bin bash, and now this is basically my child shell. How do I know that? PS AJXF. Now you see I have a child shell here. Okay, so my variables are created here. Local var is also created here, and my environment variable also is created here. But which of those variable is accessible here, right? How do I know that? I will again do echo $local var, and you can see that it does not display any value because the local var is not accessible in my child shell. Currently I am at a child shell, right? So it is not accessible here. But if I do echo $env var, you do get the value. What does it mean? That even though environment variable env var is declared in my parent bash, parent shell window, right? Parent shell, it is available in the child shell also. So in case if I run any shell script in this child shell or if I run a shell script in my original shell, this environment variable will be available there. But if I run a shell script in this shell, it will be available there. But if I run it here, it will not be available there. Okay. So these are the two types of variables that are available. One more small thing. In the system, in the Ubuntu system, whenever we are installing the system, there are many environment variables which are already created for us. Okay. And they are the examples which are given over here. So there is a shell variable, there is a path variable, there is a user variable, and there is a home variable. How do I know all the environment variables? How do I check all the environment variables? There is a command called env. So if I do env, it displays all the environment variables that are available to me right now. Okay, so you can see that there's a shell variable, right? So all of these are your environment variables. There is a home, right? So home directory, what is your home directory? What is the user who is logged in, and the environment variable that I created, remember, right? So this is my child window, which also shows that this is my environment variable, which I have created, right? There is also path variable, which is given. So path environment variable primarily basically has a list of folders, list of directories where the operating system will look for executable files. Okay, so when I'm running ls command, actually this ls command is available in the bin directory, right? But I don't have to actually specify bin/ls. I don't have to do that. Why I don't have to do that? Because ls command is available in the bin directory, and the bin directory is actually in my path environment variable. It will be here somewhere. See here. Right? So basically what it is doing is whenever I'm typing some command, it is looking for that command in the list of directories that are listed here. If the command executable is found here, then it will automatically run it. If the command is not found here, then it will not run the command because it will not find it. And I do have to provide the complete path in that case. Okay, so these are the different things, different flavors of environment variables. So again, you can use the grep command with env also. Like many times I do. Let's say I want to know only the. Let's say, do I have my env var here, right? So I can just do env pipe grep, and I do that. Then it will search for. So this operator basically says that output from this command will be fed as an input to this command. That operator is called a pipe operator. Again, I will cover that more in detail in the file management and redirection and all that. But basically, just so you know, basically this operator takes the output from here and feeds as an input to this command. So whatever is the output that is coming out of env, I am taking that output and I am feeding that as an input to my grep command so that it can search for this env var variable. Okay, so that is what I am doing here. So let me stop here. If you have any questions, I can take them. Let me see. There are some in the chat. Can I run POSIX shell as SH was allocated for both POSIX and Bourne shell in the slides? I mean, you can run any shell, pretty much as long as it provides you the functionality that you need. So I'm not saying that. See, I'm saying that you should try to use Born Again shell because I know that all the system functionality that we need is available there. You can try the same with POSIX shells, right? So POSIX shell may have all the functionality, it may not. I have not used POSIX shell, so I'm not, I don't know all the functionality that we need is available there or not, but you can definitely give it a try. Okay. What does it mean for a process to be a child process of another? Well, the child process of another meaning that uh, basically it inherits certain certain properties, right? So a parent process has certain information, certain things which the child process will inherit. Okay, and I'll be able to answer this question more in detail when we talk about process management, because you have to really understand more detail about process in order to figure out what is the difference between the child process and the parent process. Okay, so I'll not be able to answer this question properly unless we go through the process management area. Reference book I've already put in the details. If you go to the course detail, PDF file, I already have the reference book there. What does it mean for a process to be child? Oh, yeah, so yeah, I've already answered that. We're not able to unmute ourselves. Could you please? Okay, I'll make sure that next week when we have the class, I'll make sure that you guys are able to unmute yourself. I'll have to figure out the option where it allows you to unmute. So I'll do that. What is the difference between command, system call, and functions? Okay, so command is basically what you type in the terminal window. Command is basically what you type in the terminal window. System call or so functions can be user function also. Okay, so if you write your own code, if you write your own functions, then they are normal functions. But the functions that are implemented in the kernel, functionality or functions that are implemented in the kernel, which you can use in the application code, that is basically what we call system call, right? So fopen, for example, is the function that is implemented in the kernel to open the files. That is why we call fopen as a system call, right? Because it is implemented in the operating system, but that function can be called from our regular C programs. So command is basically what you type in the terminal window. System call is the functions implemented in the operating system, but can be called from a user program. And this function means normal user defined function. What is S plus SS? Yeah. So these are the process statuses, right? So if the process is running, if the process is halted, if the process is hung, so these are the different status that is showing. And if you want to know the detail about that, again, we will cover that more in detail when we go to the process management module. What happens to the local and environment variable when we exit the shell? Well, the variables go away, right? So no longer those variables are available to any other shell. Okay. So that is what so basically as simple as that. I mean, if I exit from this shell, right, those variables are gone. Those variables are gone. They are not in the memory anymore. Okay, so I think that is what I covered all the questions. If you have anything else, we can cover. Otherwise, we can close for today. All right. Thank you everyone for joining.